Well, still no spindle, but it's on its way, apparently imminent. So I've been looking at a couple of things that I want to do, some modifications, and looking at what others have done. I think the first thing I'm going to do is replace this plate with a much thicker, sturdier plate with 4 fixings rather than just the 2, and that will provide a more even clamping force. Still looking at a replacement for the tool post. I think the multi-fix type A has a centre bore which will fit over the existing pillar. It's an expensive option, but we're still looking at other options. I'm going to make a piece of alley to cover that gap, probably hold it on with magnets, a piece of angle, so that muck doesn't get down there. I'm also going to look at the concertina, like on the back of the mill there, the cover, and fix a plate across there to cover the ways. I've now got a nice chuck, but that's as far as we got really, which is not very far at all. Oh, finally we have a spindle that doesn't have any dents in it. It looks reasonably okay. Certainly better than the other 2 that I had. Now, the next problem. The chuck that comes with the machine has an adapter plate on it, which and the chuck is a standard 95mm register with 108 PCD hole. This bloody thing is not standard at all. The register diameter is 52 and the pitch circle diameter is 75. To make matters worse, the holes are 11mm diameter and the studs are only 8mm. This is bloody ridiculous. They don't seem to be in the centre anyway, but maybe that's why they've done it, because that's the level of accuracy they can achieve. So, the big problem is if you want to mount more than one chuck, you're going to have to make a separate plate for every chuck. So a face plate, a collet chuck, a 4-jaw chuck, you're going to have a separate adapter plate for each one. The reason being, you cannot get the bolts through the back once this is bolted in place. So you have to either take this off every time and bolt it to the chuck first, and then bolt this to the back plate, which is not ideal. Not ideal, firstly, because you've got 2 interfaces, which will not going to do anything for accuracy, and it's a real faff. The alternative is you bolt this directly and permanently to the back and make up a new plate which has tapped holes in it, and that's okay providing the chuck, like a Pratt Bernard, if you use a decent quality chuck, they have front mounting as well as rear mounting holes. The other option, certainly for the 4-jaw chuck, if you're using a larger diameter, say a 6-inch, 160mm, clearly the holes are, I think, about 140 PCD, so they're out here. It's a real pain to trying to get anything to fit this sodding thing. Really pissing me off. But I can get the shaft on the machine now. We'll use this plate and the chuck that came with it, which is absolute rubbish, but it will get me going, and then we'll see what we can do. And another problem with this is the location diameter at 52 millimeters is actually 8 millimeters. Now that's a big location. No wonder it's difficult to get off, because you can't twist it because of the holes. Normally the location, the register is much larger diameter, so normally something like this, 95, and 3 to 4 millimeters. With 8 millimeters and a smaller diameter, it's a real pig to get on and off. So again, that everything is conspiring to make your life harder. Fine if you want to stick a chuck on and just leave it, but if you have aspirations to do anything else, then you are in for a rough time. I suspect the reason they have done this is just cost. This is 100mm diameter, and they use this for a variety of the casting, the basic casting. They use it for a variety of machines. Rather than use 125mm diameter as a starting point and machine it down. And your problems don't stop there, because if you want to fit any chuck on this machine, you have to have an adapter plate. And the way this is configured, the bearings are back here, so there's already about an inch from there, plus 20mm, 1.75 inches before you're mounting the chuck. Chucks generally are this size, 5-inch, 4.7 kilograms, say 5 kilogram tops. That's a big chunk, and it's just not good for stability being that far out from the bearing surface. We're almost ready to put the spindle in. Make sure there's something out there, just in case something happens and it drops out. Everything's nice and clean. I will grease it before we assemble. The spindle itself is in the fridge at the moment. Laid all the pieces out in the order which they're going to go on. It's worth taking the time to do this now, rather than when you're actually trying to do it and finding stuff. So we're going to heat these bearings up. I'm going to use a syringe full of grease to get it in there quickly, then assemble it on the shaft. So it's all about preparation. The actual job itself hardly takes any time at all, but making sure everything is clean and ready is always a good idea. At last. Well, I've calmed down a bit now. It's been months getting to this point. But the thing is working. I haven't got the tool post yet. That should arrive tomorrow. I've had to adjust the angle of this, take everything off and file the holes out a little bit, because it was just a bit too close to the chuck. I may wire in a switch to disable the safety cutout on this, because there are some instances where if you're working really close, and certainly when I use the collet chuck, I'll be working quite close to there, and that will be more of a safety issue being in the way than not. Right, onwards and upwards. Well, at last we have everything assembled. I did try to take a video of the assembly of the spindle, but it turned out to be an absolute pig. You have to heat the bearings up. Sliding the first bearing on was fine. The bearing at the back, it just got caught, and 2 hours later trying to wrestle it off without damaging the bearing, it was an absolute nightmare. Finally had to reheat it to get it on, and all was good, but it's taken a while to get it adjusted. Now we're starting on the setting up, and I think again I'm due a bit of luck, and this is it, because it's pretty well perfect. I haven't adjusted it. I just sort of set it roughly, and as luck would have it, it's just, say, perfect. With the belt tension, probably doesn't need to be really tight. From the factory, this was really tight, which was why it was making a funny noise, but seems to be okay now. Everything meshes nicely and it's smooth. I've had to nip up the bearings a little bit, and I will probably readjust them in a month or so when I've run the thing. The good news is at the moment, there seems to be no perceptible run out at all. There's a little nick in the surface, which is probably why it's, but basically it's pretty much zero run out there, which is good. The run out on the face seems pretty good as well. Pretty well sod-all. I'll take that. I've also verified it by coming up and just winding this in to 0 and then checking in various places, and it's spot on. Yeah, very, very happy with that. All the aggravation with spindles, worthwhile. And the guys at Amadil have been great. Took a long time. We got there in the end, and the end result's definitely worthwhile. I'll take 0 run out any day. Well, I didn't want to do this, but I had to dismantle everything to put the new oilers in. I was lucky to get hold of them, because they're metric. All I could find was imperial. But anyway, I didn't want to hammer them in on the bed, so I've had to take everything off. But it did give me an opportunity to fix the carriage lock. And I didn't have the right bolt, I only had a flange bolt. But I've got a mill. So I put the new carriage lock on, which just consists of a spacer and a bolt, so that you can access it like that, rather than trying to get down there. It was possible, but this is much more elegant. Well, it is now running. Very, very noisy. Well, it was at first, and the problem was there wasn't enough preload on the bearings. There's nothing to set it. It's a bit of trial and error. As the speed went up, it made the most awful noise, and I wondered what the hell was going on. I thought it was a gearbox. Disconnected the gear train, and it was still there. So it was just, when you tugged it, you couldn't feel anything, but it only needed just a few degrees on the clamp at the back, just to put enough preload on there. And I will probably have to do it again as it beds in. So it's difficult because there is no setting, there's no figure, it's just do it up tight. I'd rather start on the loose side rather than over tighten it. Yeah, we'll just have to run it and see how it goes. I mean, the gear train is noisy, just because there's lots of gears there. But I think that's normal. What isn't good is when you turn it off, it doesn't stop immediately. If it's going at a higher speed, it will stop faster, probably because there's more back EMF. There is a bloody great resistor in there to provide that, which is switched in when you turn it off to stop it quicker, but it's not exactly brilliant from a safety point of view. Yeah, well, it is what it is. I think it's as good as I can make it, and we'll start on the little bits. Still waiting for and I should get the new tool post next week, so we can put that on. So now the new oilers are in, and the new carriage lock arrangement works fine. We backed to where we were several weeks ago, but at least we've got a chuck on, and it's turning now. Another little job done, just a little cover to stop muck going in there. It's just held on with the magnets. I do like magnets. No drilling, and it's quite secure. But if you need to take it off quickly, there's just a couple of magnets stuck in there, and job done. Yeah, get in there.